problem 174 dungeon game. Let's try to understand the problem. So we are giving a grid. So this dungeon is a grid. So there's a people coming from top left corner, and we'll go to the bottom right corner. From the beginning, so this guy will have at least have a score of 1. But if he step at this area, but if this guy step at the top left corner, it's gonna be 1 minus 2. It's gonna be negative 1. So it's gonna stop the loop immediately. He cannot go anywhere. So it means this guy should always have a score more than 0. So, for example, this guy can go to the go to the right side or go to the down side. Yeah, only 2 directions. So we're gonna return what is the minimum value this guy should have to go from the top left corner to the bottom right corner. So how can we make that? So for example, if the initial value is 7, so 7 minus 2, it is 5. Now from here, this guy have a score of 5, and if you go to here, the score is 2, and go to here, the score is 5, and here is 6, and then go to here, it is 1. So no matter which position, the total score should always more than 0. We just need to check which minimum value we should choose to make it possible. We can use BFS, but BFS will got a time limit exceeded, because if you use BFS, we cannot use a weighted set. Yeah, so in this example, for example, so if we want to reach this target, so for the BFS, so it can come from here or it can come from here, but it does not only have 2 states, it will have too many different states. It can come here, so for example, it goes from down to this position, or it go to right to this position. But from the beginning, what about this position? It can go like this, or it can go like this. Yeah, because there are too many states, so that is so difficult to use BFS to record the weighted set. So in this way, we have to use dynamic programming. So we can use a binary search to guess if which value is okay. So for example, for the first example, maybe we're gonna guess as 14, maybe it is too large, and we're gonna make it smaller, 7. 7 is okay, 14 is too long, it is true, it is too large, but we can make it smaller, maybe 7. So next time 7 is okay, maybe 3 is not okay, and maybe 5 is not okay, and then we go to 7. So we're gonna have a value of 7, it's gonna be the minimum. So the difficult part maybe comes from the dynamic programming. And how can we do that? We can use DFS plus memorization. So we're gonna start from this position, the top left corner. So from the beginning, we have a DFS. So the DFS, we have the position, it's gonna be 0 and 0. But we're gonna have initial value. So this value gonna be the threshold. So I'm gonna give it as. So with this value, I want to check if I can go from here to the right side, or I can go to the bottom side. So yeah, so from here, if it is a positive value, it means yeah, definitely from here, I can choose 2 directions because this is a positive value. And then if I go to this position, I want to check what is the result, if it is positive or negative. If it is negative, I'm gonna stop immediately. If it is positive, I will go down side, and then I'm gonna choose 2 directions, right side and the bottom side. And if this is not okay, I will just choose this way. Maybe this is okay, and maybe this is okay. It is always positive, always positive. So if I can go to the bottom right corner, it is always positive, so I can return a true. So this means for this DFS, it is true. So it means yeah, I gonna choose this value. Maybe I gonna choose a smaller value. So this is the process of the DFS. Definitely we're gonna choose two directions. If we go out of the boundary, we're gonna have the boundary attack. Definitely we cannot go to the bottom, go out of the boundary. So we have a boundary attack also. Yeah. Now let's try to write the function. So we're gonna use a memorization with DFS. So I will give a pass at the moment. Let's first write the binary search function. So it's gonna be L and R. I'm gonna have a result. So this is my template. You can choose any template as you like. So 10 to the power of 9, 10 to the power of 9, and the result I gotta set it as 1. This is for the left side because the minimum value should at least have 1. So what about the maximum value? So the maximum value is that for the dungeon, the minimum value, dungeon IJ, the minimum value is minus 1000, and mn is 200. If m times n, it is 4 times 10 to the power of 4 times 1000. Yeah, it is more than 10 to the power of 7, so I will give a value of 10 to the power of 9, just to keep it large enough. So let's first finish writing the binary search. So I'm gonna have the m, it should be L plus R minus L divided by 2. Now I'm gonna use a DFS. So it will always be starting from the top left corner. It's gonna be 0, 0 with m. So if this is okay, I'm gonna record my result should be equal to m, and it can become smaller because this number may be big enough, or otherwise, if it is not okay, so the L pointer would be updated to +1. Finally, we're gonna return the result. Yeah. So this means if the target is 7, if we choose a value 14, maybe too large, we're gonna make it smaller. Yeah. Maybe we choose a value of 3, it didn't work. We cannot go from the top left to the bottom right. So we're gonna guess a bigger value. Maybe this value gonna be, maybe we're gonna guess a bigger value. So the left pointer may be 4, and the next pointer may be 10. Maybe next, we're gonna choose a bigger value. Definitely we're gonna choose the bigger side after this 3. Yeah, if it is not okay. Now we are going to write the DFS. I'm going to prepare R and C. This is the initial position, and inside I'm going to give a threshold. So I need to prepare another 2 variables, R and C. It would be the length of the dungeon and the length of the dungeon 0. Now I need to have a boundary tag. So if this R is more than equal to R, or this is C more than equal to C, and definitely I gonna return a false. Yeah. So from the beginning, I just have a threshold, but I don't have the value inside the cell. I need to have this value. So I'm gonna prepare another variable as total. It should be the threshold plus the value. It's gonna be dungeon with the R and C. Yeah. So this is gonna be the value at this point at the top left corner. So at this point, I'm gonna have the value. It is the total. So I need to check it if it is more than 0 or less than 0. So I can check that. But I need to check the return first. If R equal to R minus 1 and C equal to C minus 1, so I'm gonna return a true. So if this total is more than 0, so this means for the final state, if I go to this position, so this total is the total value. It means from this value before plus the minus 5. If it is more than 0, so I'm gonna return a true. Otherwise, I'm gonna return a false. So if I didn't go to that position, definitely I'm gonna search left and right and bottom side. So it's gonna be DFS R plus 1 C with this total. Yeah, because from here, so for example, if I were to go to the left side, so from here I need to get this total value. So this total value is minus 2 plus a threshold, and then I'm gonna use this total value plus minus 3. Yeah, for the next total. So, and then I can go to another side. It is RC plus 1. So this is to the right side with this total. Yeah. But if I return from here, I'm not sure if it is more than 0 or less than 0. So what about I just have a check? Yeah, so if this total is more than 0, I'm gonna have a return. Otherwise, I have to check from here. So if this total more than 0, I just check this direction. If it is less than 0, I will not check it. I will stop it immediately. So that is why I will have an if check. So this is the entire code. And the time complexity, as you can see, so this is a log 10 to the power of 9 for the binary search, and this R and C is for searching inside a grid. So it's gonna be m times n. It is 4 times 10 to the power of 4. So this is why it works. Now let me submit it to check. Let me just run it to check what is wrong. There's non-type. Yeah, because I used plus, definitely it's gonna be non-type because Boolean cannot plus. I have to use or to check because that will be all the combinations. If there's a possible case, I'm gonna return true. Otherwise, I'm gonna return false. Yeah, now it seems works. Now let me submit it to check. Yeah, as you can see, it works. I think it is slow because we use the binary search. There is a greedy idea, but I think that is too difficult to think about it. I think the binary search is the normal way of thinking about this kind of a problem. Maybe for the time complexity, we use the memorization, and also for this kind of R and C for different. We just need to analyze for one loop. So for example, for one loop DFS, for this one. So we're gonna have DFS. Actually, this DFS it's not 10 to the power of 4. It is we need to check like that. So for each of the time, it is 10 to the power of 4 for this DFS, but it's gonna have a log 10 to the power of 9. That is because for each of the DFS, we have to check so many different cases of the threshold, and then we need to times a threshold. So it means this value times this value. That is why it consumes the time, because log 10 to the power of 9 square. Basically, we need to time 2 times this log, but it's gonna still be a smaller value. That is why we can pass. Thank you for watching. See you next time.